In this video, we're going to write an algebraic formula from a pattern described in words that we'll obtain using a table of values. The question says, the staff at a restaurant have a party of 28 people coming in for dinner. While they have plenty of space, they aren't sure how many tables they will need to put together to seat so many people. And we can see on the right-hand side, there's a diagram of what the tables look like when they're pushed together. An individual table will seat 6, but if you push 2 tables together, you'll lose those seats on the end because now there's connecting tables. The table of values here says part A of the question says complete the table below to discover the relationship between tables and diners. If we have one table, that seats 6 people. If we have 2 tables, that seats 5, 6, 7, 8, 9, 10 people. If we have 3 tables pushed together, that seats 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people. We can see here we've only filled half the table with the diagrams that we've got, so let's look at the pattern. If I were to add another table, I would be able to get 4 more people seated on that table. And so if I had a 4th table, I would have 14 from 3 tables plus 4 more would give me 18 people on that next table. If I were to then have 5 tables, once again, I'd seat 4 more people in the middle like represented here. We've already got the 2 end tables that have the extra people on them, but any middle tables we add, we'll only be adding 4 more. So 18 from 4 tables, if we add 4 more, that brings us to 22 people seated with 5 tables. If we had 6 tables, once again, that is 4 more people being added. And so that would give us 26 people seated if we had 6 tables. So part B says describe using words the pattern that relates the number of tables and the number of diners. So we know each time we gain 4 more seats when we add additional tables. We gain 4 more seats for our diners. And so the problem with that is we've got the 2 extra end seats. No matter how many tables we have, we're going to have 2 people seated on the ends. So 4 people for each table plus the 2 people seated on the ends. So the number of diners is 4 times the number of table because we've got 4 people on each table. 4 times the number of tables. 4 people for each table plus the 2 end people that we have no matter how many tables we push together. Number of tables plus 2. Plus 2 people sitting on each end, which we've highlighted there in blue. So now we can use that rule to write a formula using our variables. We haven't had variables assigned, so let's choose our own variables. For me, it makes sense to call the number of tables T and the number of diners D. D for diners and T for tables. They're the variables that I will use. So we've got number of diners is D. Number of tables is T. And we've got 4 times is our first operation. So if we write this algebraically, the number of diners, D, is or is equal to 4 times the number of tables. You know the number of tables was represented by T, but then we also have to add on those 2 more people that sit on each end, regardless of how many tables we have. We've got our formula, but to make it a little bit more concise and a little bit more algebraically correct, we need to write it without that multiplication symbol. So the best way to write this formula is the number of diners is 4t, 4 times the number of tables, plus 2. And now we can use that to predict how many tables we would need for a certain number of diners. But we could also see from our table that if there are 28 people coming, we would need 7 tables. We need 1 more to make sure we've got enough seats for them all.